Hey, Algebra 1, back with another video here. Today we're going to take a look at types of functions, their properties, and what their graphs look like. Look at this screen right here. We've got a couple of examples of linear functions and some non-examples of linear functions. What you should notice if you compare and contrast the two groups is that if we focus our attention on where x is, notice how we have an x here, we have an x here, an x right here, and then an x right here. And then if you look at the non-examples, we've got x squared, square root of x, another x squared, and then x is the exponent here. Okay, what you should notice here is that x is kind of by itself, and more specifically, x is raised to a power of 1. Okay, what I mean by that is this. Okay, if we look at x being raised to the power of 1, we can just simplify this to mean that we have x by itself. That's what we see on the left group compared to the right group. Okay? So let's say, for instance, I wanted to graph this on a TI-84 calculator. Here's what we would need to do. On the top left corner, you see a y equals button. You're going to click that, and then what should pop up is a screen of y1 through, I think, y7. Okay? And we want to test out the function y equals x plus 3. Here's what we do. So as long as y1 is cleared out, here's what you can type in using these following keystrokes. You use x, t, theta, n, okay, and then the plus sign, and then obviously 3. When you're done doing that, once again, these are just buttons that you put in. These are keystrokes. You're going to hit this trace button, which is 4 buttons from the right, or from the left, I should say, and that allows you to find out what x and y values work here. Okay. Obviously, I have the line already graphed here, but I wanted to show you how we get this line. Okay. So I'm going to pick 5 values for x in my calculator. Okay. So I'm going to pick 3, 4, 5, 6, 7. And obviously, I'm going to add 3 to them because that's what our function tells us to do, is that y is going to be whatever x is, and we add 3 to it. So 3 plus 3 is 6, 4 plus 3 is 7, 5 plus 3 is 8, 6 plus 3 is 9, and 7 plus 3 is 10. That gives me 5 ordered pairs that I can graph easily. So 3, 6, well, that's right here. 4, 7 is right here. 8, 5, 8 is right there. 6, 9, and then 7, 10. Notice how they're all on this straight line that I've drawn already here. Okay. Now the reason we draw in the line between there is that a graph enables us to see every single point that is defined by this function. That includes your decimals, your fractions, anything in between those points that we've drawn is also fair game to be defined by this function. So once again, that's why we fill in the spaces between the function. We're not going to be able to it's not humanly possible for us to account for all these numbers, but at least we have a visual of what that looks like. Okay? So some properties of these functions. Properties of a linear function, it graphs a straight line on our coordinate plane, our xy plane. Okay? It also contains a slope, which we will identify in our next unit, and it also has a y-intercept, okay, as well as several other points. But these are the two we're going to be focusing on. And all a slope really is, because we know what a y-intercept is, all a slope really is this. It is a ratio taken by looking at the rise over run. So taken by dividing the change in y, which is once again our vertical, by the change in x, which is once again our left to right. We have heard of this already, known as rise over run. Okay, so all right, so that's one type of function we're going to be looking at. There are 2 more coming up, so make sure you stay tuned.